Hi, I am live coding a refactor. Wes Boss posted a project on Twitter a few days ago, or the other day, and it is a pretty cool little project. But I noticed some patterns that I see all the time that lead to some difficult to fix issues. Now, this was one, if you scroll down this README here, you'll notice that there's a mention of dealing with rate limits and okay, so there's some weirdness here, and there's a little bit of a code fragment giving you an idea of where to start to insert this kind of a code fragment. Now, the code for this project is relatively small. It is very manageable and fairly digestible, like 100-line main file, couple functions. So the question is, like, there's a state where an engineer gets into and they overestimate the simplicity of something like this. Because, I was able to parse this, and it only took maybe 20 minutes to really get an idea of the flow and be able to refer back to it later. Really remember it. So let's take a look real quick at that flow. So you'll see there's this go function at the bottom here, and it just has three discrete functions, or three distinct top-level functions that it calls. You'll notice that they are being called with async await, and then there's also a couple functions in here that are used inside those top-level functions. So find last tweet is one of them. Get list of people you follow. Let's look at where that is. So get list of people you follow is a top-level function. Here's that next cursor bit that is where that await would go. So, but again, that's immediately getting to this point where our code is suddenly getting a little janky, or we have to shoehorn some stuff in here. If there's errors or rate limiting issues, and really at a high level, when you're accessing an API, ping, 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 hey, headers tell you, whoa, wait, slow down, buddy, and you keep going, you may get a 400 error just telling you to quit it. You've exceeded your limits. And it's very common with things like GitHub or Twitter's API. If you've interfaced with any of these types of APIs, you've definitely run into this. Or if you haven't, you will soon enough. So what I want to show you is a library called functional promises. It is a library I built to deal with these sorts of what I called a functional river, where you have a series of discrete steps, or a series of steps that are being processed in sequence, and they correlate highly to named variable or named functions. So workflows like data processing, ingest, data transformations, any pipelined sort of processes are exactly what functional promises is all about. Now, a lot of the features here were inspired by Bluebird, RxJS, RSVP, several other promise supporting or promise inspired libraries that add behavior or add features on top of the basic promise.then.catch API. So let's take a look at integrating this. So let's grab our install, and let's grab our project here. So I've already cloned it. It's local. I just was running the project, and sure enough, unhandled promise rejection warning, rate limit exceeded. So the challenge is, how do we make our code just handle this like it's nothing without having to re-architect things? And now, to get to that point, I'm going to have to actually bundle up or extract a lot of these little steps into tinier functions. It's going to seem like a lot of surgery. But, this is almost like a party trick I can do, because I can do it blind on any code base in any style JavaScript. And as long as you've got the data's local, there's no global craziness, as long as I can observe all the steps that are going on, this is going to model how I can go through this process and just refactor code blind. That is the or refactor code without actually seeing the larger picture, without reading documentation on the project. I can usually just jump into a pile of async code and start refactoring it. Assuming it's already close to working, I can keep it working at that level and make it far more usable with functional promises. So let's get that thing installed. Okay, and we're going to import it as FP functional promises. Okay, so here is the key things I'm looking for. I'm going to prioritize taking things into tinier functions. So things like a transform step, where we're taking users and reshaping them to have a username, name, and ID. Things like that are really easy to extract out into named functions. So as you're refactoring, you either start at like the most inner nested chunk of code, and you do that because it's going to have less side effects or less other variables to deal with. So you want to prioritize the ones without side effects, like this one. So user is being used to supply all the details for this new object shape, and that is something that we can extract out just like so. So I'm going to take that and say transform dot followers. So I'm going to create a file here, transforms.js, export, and I want to say followers equals. Okay. So this is transforms.js. Okay, so let's actually rename this to be consistent. Okay, so now we've got that extracted. Now let's keep going, and let's see if we've got any other low-hanging fruit here. So there's a couple functions that are nested inside this find last tweet. So let's scroll down and check those out. So we got a filter, we got a map, and another map. Okay, let's see. Even if these were huge functions, by the way, we could just copy them out into our new transformers file and see if we get an error about a variable not being available. Then we can eliminate potential scoped variables being used from that function or hoisted from somewhere else. So let's figure out a name for this, and that is going to be some kind of transformer, because we're taking an object and immediately returning a differently shaped object with formatted times and some more helpful specific values. Interesting that we've got a snake case and camel case names. Something to be wary of when you're doing these sorts of transformations, or doing anything at all. You can get in a world of hurt very quickly if you forget what kind of naming conventions you're following. So let's name this. I say this looks like we're assigning a last tweet time. So user last user with last tweet time. So these are the only case of like awkwardly named functions I embrace, where the transformations should be very descriptive of the parts or the thing that's being done. So let's take this user with last tweet time, and let's go and okay, and then here this looks like set user status. So I'm gonna cut that. Transforms. Okay, and okay, so there we go. We got a set user status, user with last tweet time, and now we've got a method that prints out a console log and returns it, and then we do the filter. So this isn't quite a transform. This is just a status message, and you can't just do a console log on its own because it'll drop the console log returns undefined. So that's why these are on two separate lines. You've got a console log and then a separate return user. Cool thing about fpromises, when we've integrated it, there's a .tap method, which allows us to basically make this a one-liner and not have any weirdness in here. So we'll leave this in here for now, but just know this is where we're heading. So we'll get to that in a sec. Let's take this final filter arrow method. So let's see. So cut limit is that 280 days value. So if you haven't tweeted in 280 days, you will be you'll make the cut list. So let's go and filter here. So this is going to be a transforms. So this could either be in like a helpers or in a specific filters shared JS file. For now, let me just throw it in transforms, even though it's probably not where it's going to live. And the reason that's not exactly a big deal is because it is very easy to move pure functions. Like if a function is has no side effects, we'll see that it can move pretty much freely within your project, between files, and some editor configurations can even make that super simple and automate, adjusting imports. So let's go and write this with a more specific label here, so you know it's a filtering, or you know it's a predicate function, which is a fancy term for something that returns true or false. So is active Twitter user poster, whatever. Let's paste this, and suddenly if you've been following, you'll notice cut limit. Where does that come from? So one of the cool things that you can do when you do have a side effector, you've got some external value. Guess what? You can just drop it in like this, and now if we save this, we can do something like so. Is active Twitter poster cut limit. Okay, so cut limit is actually being passed in the first time we call this. So here is a method that's being called right away, or and it's actually returning another function. You can see that in when I hover my mouse over, you see cut limit any, fat arrow user any, and that returns a boolean. But we're calling just that first cut limit any, and then the next user any is what's returned and is basically running in place here. You may know this as a currying partial application. There's a couple jargony terms that describe this, but actually, let's just get this consistent. I want to make this a helper as well. Even though I said we're going to use tap, which we will, I want this to be consistent. Maybe it's my OCD. So I'm going to say transforms show user info and so show user info. Okay. So now we've got a index.js. At least our find last tweet is looking a lot cleaner. So okay. Save that. Here we see there's another pattern that's really common with promise-based workflows, and that is chunking your work that you want to do so that you're not overloading your server or your async database or callback queue or just your computer's resources. I mean, if you try to download a queue of 1 million photos all at once in promise.all, then you're going to have a very beefy machine. Promise.all does not just solve this magically for you. So the thing with promises is they're eager. They start before you really get a chance to tell them to start. So the second you start requesting data from a server, well, there's no pausing it. There's no telling it to stop. Cancellation aside, there is a challenge here. Every time you create the promise, you now have to hope you have the resources on the computer to handle whatever comes down. But here's where it'll break if you don't. So promise.all user promises. So Chunkify here is basically trying to deal with this issue of dealing with the data in chunks, because you could have thousands or millions of users, and that just doesn't scale. So Chunkify, let's just show you the local method here. It's basically creating a parent array that is going to have its data cut up into whatever chunk size you give it. And so its default is 10. I think we give it 100 in the other in the index. Basically, this is an array of buckets of data. And this is a little awkward to have to integrate and think about and then work with the data on the other side. There are some ergonomic issues or developer experience issues around this. So again, let's look at how functional promises solves this. So there is a telltale indicator that this could benefit from functional promises based on the fact that we've got a map and we're doing promise.all. Find last tweet does a bunch of things. We just refactored some of it. In fact, let me save my progress here. So let's check out and do let's tackle making this flow a little bit better. So the thing here, the reason this was failing earlier with this rate limit exceeded is because, well, obviously Twitter has rate limits, but also we have the situation where find last tweet, like we're getting all this progress coming down from our API or from the Twitter API. But then we wait for all of it. We wait for all the data to come down, and that is only after we've thrown like possibly hundreds of concurrent requests to Twitter's API, which understandably they're responding with a FU, rate limit exceeded. So what's happening is we've got a really kind of brittle process where it has to fully complete before there's any indication that it's even partially successful. So how do you design this to save each incremental step? Well, that's only happening here on 57. db hydrated users save, and it's using the new flatten array method to take the chunk data back down into something manageable. If anything fails above this line 57, it's 0% works, and we can't like restart it. It's not very easy to design like that. So let's look at how we'd refactor this hydrate users with functional promises. So first steps first, we take the data that we're working with. So the db users find. We're no longer going to need to chunkify that. So let me just comment out our code there. This is going to be a little bit different than the refactor we just did in find last tweet message. But here is so here's the first step. We need to turn our data into a functional promise. So this gives us all these cool methods. So find, map, all these arrayish methods. And we also get the ability to specify concurrency. So concurrency is what limits us and allows us to run promises, X number of them at a time. So in order to use that function, let's look at this map function. So find last tweet, we just need to map over that for each of our users without, blowing out all our call stack or our computer's resources. So let's look at how we can do that without chunking it, doing an optimistic promise.all and then flattening. So let's do it this way. So map. Okay, very similar to what we have here. And we don't need the user promises promise.all bit. The step here, so find last tweet, okay, promise all. Okay, so we want to do chunks of 100. Well, that still might anger their API. So let's just do 4 at a time. So concurrencies, you want to map to the number of processors or cores or threads you can run on your computer, generally not equal to all of them. You don't want to run into a situation where your computer is redlined at 100% and you can't do anything. So just specifying a number 2, 4, 6, or 8 here is a good practice. There are ways you can pull out the CPU count on your system if you want to get fancy. But just a rule of thumb, I usually start with 4. And what this is going to do is make sure that no more than 4 of find last tweet can operate at any given point in time. When it's done, it's just going to have that data available at the end here. And what's happening is we're inserting it into db hydrated users. So let's go and capture that. So instead of .map, we're going to use .then to get the results of that .map. So this is going to make the features or the behavior mirror the previous behavior very closely. So results. Okay, that's basically it. So this does not solve the issue around where we have our where progress is basically lost if we have an error. So let's leave it like this for now, and we can come back and deal with this later. And by the way, the reason I didn't just put db hydrated users.save in here, like so, is because I don't know if save is using a implied context. This doesn't, it's a little bit much to assume that would work, but it's worth testing. This is at least a guarantee that it's going to execute db hydratedusers.save in the same way that it was running down here. I just have to nest it with a explicit arrow function. So I don't want to get into context here, or the weirdness around how context and objects work in JavaScript. That's another video. But here is the hydrated users without the extra step of chunking and all that. So let's go down to these other steps. So let me save here. And what I want to do is, let's see, so getting, so this is probably where the chunking of data is useful, because it looks like we're actually passing an array of screen names. Okay. So this is one of those things when you're dealing with an API that has rate limits. You either want to balance like sending them a huge chunk of work based on like how often they throttle you, if it's like requests per second, but no limits on the data size. You may want to send a huge chunk of data like once a minute even, and then just get a massive data dump. Depending on how that's actually, how rate limits are calculated, it will impact like how you design that. But again, this is one of the benefits of tiny named functions and then pairing that with functional promises. So screen names here is going to just be singular, and so this is basically going to run through every single user and send 4 concurrent requests here. Now, that could easily overwhelm the system. So one of the things we might want to do is do a fp.delay. So that is built right in. One way we could do it would be just chaining off of this t.post users lookup. So let's actually turn this into its own little function. And this will be easier to model out. So this is going to be a function called users lookup. Users lookup. And screen names. And what I want to do here is just return our return this users object, or the results from our query here. So return users, and I don't necessarily want to use async await here. Let's try to stick just to promises. I know that it can get a little, it can get really confusing switching between. So I recommend just picking one and sticking with it. As you build up fluency with async await promises, it gets easier to switch contexts, but even still, the subtle bugs can creep in to your code base if you're just mixing patterns like that. So be careful, pick one and stick with it. Consistency wins in the end. So here, let's take our screen names. So we're returning our value here. Let's say then. And so this is where we can do our extracting of the data. Destructure that. So we're pulling out the data key, and I'm just going to return it. Okay, that is basically the same as what we had before, where we're extracting the users or assigning them to the data key. Or yeah, so users lookup. And so the nice thing about the using just promises instead of the async await, my error handling, if I'm consistent, is going to get a lot better, and we're gonna see some tricks there in a second. So here we have users. And notice this is what we start on. So let's turn this find last tweet into a functional promises deal. So the way this works is, don't blink now, you might miss it. So return, and instead of users here, we're going to pass in users lookup and screen names. Okay, this is basically identical, and we do lose our cut list console log here, but we also lose the cut list temporary variable. We've created just a chain, step 1, step 2, step 3, just pounds through the lines. And now we've got a pretty tight function here that is really helpful. So let's go and let's keep working through here. So let's go and clean this up, finish up some things here. So we probably don't need comments like this, by the way, when you use this functional river pattern, where you have a chained series of functions that, well, they're named functions. They provide the description of what you're doing right there. This is a great way. This is what like self-documenting code is about. Not, oh, I can read your code, it's easy to understand if you're experienced. No. Use human words in your code. The challenge is not doing it using comments. The easiest way, tiny named functions. They have to have a name, and the more pure they are, the less side effects they deal with, the more you can focus and create really helpful and specific names to describe what they're doing. So let's clean up some of these. Okay, that's looking nice and clean. So let's actually put some of those logging things that we had in here. Let's put those back. So tap is a way to grab the data that's coming out of the chain, out of that step in the sequence, and gives you an opportunity to console log it in a one-liner without worrying about the return value affecting the next step. So let's go and put in a results. I guess this is going to be their last tweet, I believe, or okay. So tap is going to get our console log. And I like to put a label in here so we know where it came from. Find last tweet and results. Cool. And I think we're using semis here. Yep. Okay. So let's keep going down this path. And actually, let's take a second to take note what one of the patterns I'm using here. I'm always returning. Always, always, always. In fact, it's basically the first thing on every function. It's a way to tell you that there is no other code beyond this chain at all that you need to worry about. Anything after here, if I put a console log, blah, nobody runs me. So this is all grayed out because it will never get visited. The return is going to evaluate all the lines in the chain, and that's also why I start the chain with a dot on the next line. You may have seen the dot on the previous line. It makes it really hard to tell if you're in a functional chain like this. And this is just a way to focus and help the future you or some other developer looking at this. While this pattern may be unfamiliar, it at least narrows the scope and the sprawl of all the things they need to evaluate or look at when they're reviewing your code. So let's complete this refactor on these last functions here. So let's look at what they're doing. So hydrated users is using the diskdb to pull out our hydrated users. So hydrated probably means the users with their last tweet information combined. So that is also being stored on the step. List of people you know. Okay, so get list of people you follow. Okay, so this is the next function to refactor. So again, the reason that we were using that return right away is because it is super helpful to narrow the focus. Like, let's take a look here. Let's just take a look on a not too crazy example why this is hard when it's written this way. So we have get list of people you follow, and it calls the next cursor. So we have this db save step that keeps going through this list, and each time we are getting a list of your friends, count 200, and the cursor is used to check to see if Twitter's giving us paged results. So next cursor means there's another page. Well, cool, but this process is not being is going to be vulnerable to issues around the async await sequencing. If there's another async method here or anything else like that hidden in these map functions, you could end up in a world of race conditions and all kinds of weird and hard to deal with issues. So one of the best defenses against this is using tinier functions that always return. And what this does is it forces the cascade of functions that form your steps. It forces them to wait on every single next step, and it makes it clearer the pathway even through recursive code. So if there's a next cursor, keep calling this, but there's the way this is woven together makes it a little hard to process. So let's go and break this up. So again, let's just take out this data piece, or the friend list query. And so it looks like we've got an environment variable. This could easily be a side effect or an issue, so we probably want to make that an explicit argument. So let's say function get friend list, and so here we want to return again, and because we were extracting the data key out of that, let's go and just making sure our next cursor is on the data object. So let's go and, similar to how we pulled out the data object here, we'll do the same there. And this is just going to be username. So username. So now this is a pure function. Well, not pure from the point of view of the calling code. It does reach over the network. But in terms of local variables, it takes an argument or parameters here and does what you want with them. So let's make sure we're calling it the same way with that environment variable. So something like that, and let's just get it back to where it was functioning, or where it was, so it's got feature parity or function parity with the last version. So here, and again, this is async, so this is not going to work. We're going to have we'll get a warning if we try run this that the users.map is not a function. That's because it expects data.then. So let's force ourselves to use a functional chain and promises. So again, because we see these .maps, that's a dead giveaway that we can get rid of these temporary variable names and just go ahead and save directly the, connect the series of steps and lead to more durable code. So let's go ahead and, or not more necessarily more durable, but it's definitely more more traceable, even if unfamiliar. So again, we don't need our follower set temp variable. We don't need like a const data, but let's actually start off with what we need, and that is a fp.resolve. Okay, that just turns it into our functional promises object. So our next method is going to be we're going to need to get the users and map over it to get our followers out. So because our data key or our data object is what we're working with here, we may want to create a nested scope here because there's multiple steps or multiple needs for this data object, like the cursor. So there are these two steps that transform. There are these two steps that transform our user data and get a follower set. And those are returned as screen names. So let's make sure. So we can probably do this inner function as synchronous. We're dealing with synchronous data structures anyway. So let's do a data.users, there we go, .map, and then we just need to .map again. Okay, I believe that is got parity. And for this one, like I said earlier, we could do a prop getter, which will just give us a helper function. And that looks like this, by the way. So export, get prop, prop name, and the next function, we put these in parens. That might help the readability. And we just want to get the key out of an object that's next passed in. So this is going to look a little weird, similar to what we have on line 21 here. But let me go and complete this. Okay, so prop name is what we return. There is a way to even support defaults in here. Okay, but basically, let's go and use this. And this isn't quite a transform, this is a helper. So there we go, get prop, and we just want to get screen name. There we go. So now we've got our screen names extracted. So the question is, we could save our DB users right after this. So if we did a so the reason we might want to change this into an FP promise chain is because we could get rid of temporary data or temporary variable names. And we do it again with fp.resolve. And now we don't have to change anything. The maps are still supported. But when we're down here, we can use a .then to get the sum or the results of all the changes here. So screen names is the result of this chain. And there we go. So this will, and let's actually be explicit here on the concurrency. I want to set this to 1 because these are synchronous. I don't think there's going to be any issue getting or parallelizing the processing here. But if it were an issue, you might want to do something like that. Because I think the default for .map is to use, I think, two or four threads. So let's keep going here. So this is going to save the results to our users table or users JSON through our diskdb. So here, if we have a next cursor, this is where we need to decide, well, do we download the next chunk of data again? So this is where fpromises really shines. So we need to conditionally do some behavior, like either call the value here or just return all the users. So watch this bit. And the reason it's nested in here, by the way, is because the next cursor key is on the data object. So here, let me go to then. You'll notice I've got a then if method here. That is really cool. So what it does is, let me actually pull up the docs because I've got some decent examples there. So let's look at our conditional section here, then if. So this little example on the right, if email equals my email, fp.resolve email, then if. So we're just saying, is the email's length greater than 5? Cool, it's valid. If not, bad email. Probably not the best email check. But it creates a very fluent way that is structured in a way that prevents you from putting too much cruft in your code. So let's take a look at how this actually works in this example. Not paste. Okay, so we're basically just asking if data.next cursor is there. We don't need the value from our previous function. We need the value from the scope here. So again, that's the reason this is nested. Let me get rid of some of this for now. So now we want to say, like, if our data.next cursor is there, then if true, we want to call get list of people you follow with that data.next cursor. And it needs to be a function. Again, promises are eager. You want to wrap it in a function to delay or allow the computer to delay executing it. So if we have a next cursor, return the recursive call to that method, just like it was before. And if not, we want to, so if we're getting into the that's it, here's your list, we want to take that out and be putting that here. So let's indent this. Okay, so if true, this thing, if false, this. That's it. Bam. And if you wanted to track any, put a notice out so that you can see the progress a little better, well, let's go and do a .tap method here. And this is going to be the users list. So we'll just say console.log. We'll just put a status message, downloaded, let's see, downloaded users.length, followers. Okay, and so this is a Granted, definitely it's unfamiliar pattern to most people. However, I would argue that this sort of sequence forces you to be very deliberate with what your code's doing, and tiny helper functions are a healthy way to bind your fingers, bind your options so that you're not able to just create artisanal ad hoc code. As much fun as that is, this is about putting some constraints and some predictability around your code, because ultimately if you're building with tiny functions, you can take them and run them anywhere. A lot of the time, as long as they're not hitting a database or an API, if they're just transform functions, like a lot of the methods here, we can we can copy these and put it in a REPL, or just try these in our Chrome dev tools. Just copy in a user object and then put a followers function in there and just see if it transforms as we expect. So this is extremely easy to, this technique is extremely effective when paired with test-driven development, and is a great accelerator of refactoring. It just doesn't seem like it at first, but the more you practice this, the better you get at refactoring code like so.